Okay, good. So welcome to this talk, and it's about advanced user experience with TensorFlow.js. And I'm Oliver, and this talk really is about user experience, but it's much more about finding good applications for machine learning in the browser. And I want to kick this off because I have 0 slides, so I want to kick this off with a stolen joke. Hopefully no one knows it already. So this is about user experience and, this is about user experience and the way it actually works. So hopefully internet works here. So this is what the user do. So it doesn't work quite. Obviously, guy's wrong. Fixing it. This is, I mean, because you're laughing, I know you have the same feeling as me. If you ever watched people using your user, so same thing, fixing it again, yes. So that's the joke that I stole, but obviously it worked, because I think it only works if you have some sort of experience like this. You think so hard about your user interface, and then that's what people end up doing. They will figure out how to deal with it, but maybe not in the sense you expected it. So this talk is about the same thing. Don't blame me for the styling. This is my weak spot. Oh, wait. So in a typical user interface, so disregard those buttons. Those are real buttons. The buttons down here are not real buttons, so the buttons are just here to make a point. So typically, in a very classic user interface, the buttons, they will light up when you hover over them to give people the certainty, when you click now, you will click this button. So what I had in mind was, would it be at all possible to highlight the buttons before you click them? So would it be possible that the machine learns which button are you going to click now or next? And you may ask, what could be the applications of this? And I talked to quite some user experience people, they said, nothing, more or less. And then they thought for a little bit longer. So maybe I ask you, so I get something back here. Why would you even do that? I mean, highlight a button before the user clicks on it, predicting which button is it going to be. Any ideas? Any takers? Yes? Perfect. So about flows. So actually I haven't implemented this, but with the buttons up there, that's a horrible user interface, because you need to click those buttons in a certain order, and some orders are totally don't make any sense. You get weird error messages. This would be my next step, like learn how to actually use those buttons up there, because they're complex, but I haven't implemented this yet. So what would be another reason? Why would you do that? Yes? Accessibility? Yes, so make it easier. So that was also my thought. Yes, you have another point. Yes, in the back. Sorry? Yes, preload resources. That was also something that I came up with. Someone said maybe there's a serverless function behind that button, and you want to start it up because you think, oh, the user is going to click on that button soon. You better have this thing ready. Or preload the next page. Or someone, I've written down some stuff. Wait. Oh yeah, someone came up with the idea when there's artificial reality, and it's always pretty hard to decide which detail are you going to show, and then if you can predict where the user is going to look next, then you can preload that stuff. And again, I only implemented the easiest version because I just wanted to know, is this at all possible? Could you even do that? And the easiest version that I implemented is just what you said. I highlighted the button that I think the user is going to click. So there could be heuristics to do this. You could just measure, I don't know, is the user close to a button like this? And if it's reasonably close, then you would highlight that button, which I don't do now. And you could also check, is the mouse closer to this button than to this? And it might all work, but it might not match the individual style that someone has that uses this user interface. For example, I always use the trackpad. It's extremely sensitive because I don't move much. And that might mean if I want to hit this button, I might briefly go over it and then go back. That means depending on the user that you're having and depending on the machine that you're using and how it is set up, the mouse movements might be completely different. So I'm pretty sure, I'm pretty sure a machine might identify me just by my mouse movements out of all of the people in the audience. Someone is nodding. I haven't made the experiments, but my mouse movements are so weird. It typically makes people really nervous or angry. So having said that, so what I came up with is that I said maybe it's possible to learn that those movements using machine learning. And if you want to do that, the crucial part is you need data. So the typical machine learning that we do, you need to have data. And if you don't have data, probably not going to work. But fortunately, I can generate data on the fly. And I'm doing it like this. So once I hover over a button, I generate a data set. And typically, the user would also need to click that button. But it would take me forever to generate just a few data samples if I really clicked on that button. So for the sake of this demo, I'm just counting hovering over a button as a click. This is just fake or hacked, but that's the only hacked part. And I'm doing this to quickly get some data here. And what kind of data would you, I mean, I'm generating data. What kind of data would you collect? What would you do? I mean, if you were to predict the button I'm going to click, you saw those movements, what would you record? Yes? Proximity, you could record that. I did not do this. What else? Yes? Yes, that's what I did. So I recorded XY of the mouse. I recorded the delta between the previous mouse movement because I just get this from the mouse move event. I just get this for free. And delta t, exactly what you say. So, and there's also something really special about this. I record a sequence of, so to say, timestamps. And I can show these if I find them. On local storage, there you go. So I store them in local storage, and there they are. Give me a second here. And that's how they look like. So this Y, hopefully it's big enough. Is it big enough for the back? Yeah, good. So the Y is just an ID of the button, and 2 means this one. I think so. This one should be 1. And this might be 0, or maybe this is 1, this is 2, this is 3, but I'm not quite sure. But Y represents the button. And I made this overly complicated. So X and Y don't mean positions on the screen, but they mean the input sequence. This is X, and Y is the button that I'm going to click. So this is the input sequence of mouse positions. You see, this is position X, this is position Y, delta X, delta Y, that means the difference from the previous mouse position, and this is the time step, or delta T. So how much time, how many milliseconds passed from this event to the other. And sometimes it's very similar, and sometimes it's different. So that's my input, and I did some pre-processing on that, because I was considering how many of them would I really need, like maybe 10, maybe 100. Because I didn't know, I cut all these sequences into parts and trained all of this into the model. So, but you could, like for example, what he suggested, you could have taken anything else. And if it works, you find out by experiment. That's how it works in machine learning. So you make an assumption, you try the model, and then you see if it works. And well, this might work. Let's see. So I have the data now, and now I have this this collection of buttons, and I'm the only person in the world right now who knows how to use this thing, because it's a horrible user interface. Giving a talk about user interfaces and then delivering horribly, I apologize, but that's the way it is. Now I can train on that data. So I collected some data, and I collected some data before. You see, I have 369 data sets. That means I don't know, on my way down here, from outside to down here, I did some clicks to have some sample data. And if you're at all into machine learning, having 370 samples for 3 categories is nothing. Typically, people won't even start. They will say, this is not going to work well. But maybe it does. So I'm clicking this train model now. And this is all, I have no fallback. That's why I'm having sweaty palms here. So this looks good, reasonably good. This is using TensorFlow.js. And TensorFlow.js comes with a very nice visualization library. I did not write this code. So this stuff, it comes with TensorFlow.js. and it shows you something, and hopefully something good, or it shows me something good. But I didn't know before I kicked off this thing. So it looks good. What's most interesting is these two curves down here. That's why I'm zooming in now. And these curves tell you something about how well the training process proceeds. I will show you some code later, but let's stay on the conceptual level for a while. And we concentrate on that blue curve. And the blue curve, it describes over time how well is the machine learning model able to reproduce the data that I gave to it. So I fed in the mouse movement sequences, and as a prediction, the button that is going to be clicked. And now the machine learning tries to learn which sequence spits out which button. And the higher the blue line gets, the better it is able to do that. And this is around 70% or 0.7. That means of the of all the mouse movements that I did, 70% of them the model is able to predict correctly. So I made some movements to the button, and that's pretty good. 70% on that, pretty astonishing. But what's much more astonishing is the orange line, because that is data points that the model has never seen. That means 20%, which I decided deliberately, I've taken off from the, it's done now, it looks good. I've taken off from the training data, and I'm just using it to constantly check how well the model is doing on something it has never seen. And is anyone at all familiar with machine learning? Anyone? What do we say? Does it look, I mean, would you have expected that? Who would have expected that? Maybe you didn't expect that because I didn't make myself quite clear. But this is a pretty outstanding result. So it's not something you could expect from very small training data. Training on this machine is a very powerful GPU, but it's still a laptop. Something like this typically, I don't know, it wouldn't perform that well. And I'm not quite sure why it does. This is, so welcome to the world of machine learning. You make an experiment you can't explain, it just works. That's my world. At least JavaScript is also my world, but also that. So, before we try that, and you saw, I just tried this online. We can get some more information, and this is also built into the visualization tools of TensorFlow. And I'm always so happy if I don't see any red stuff in the console, because it seems to work quite well. And this is well, I'm hiding this for a second, because what you see now is a very powerful tool. It's called the confusion matrix. I don't think it's only used in machine learning, but in machine learning it actually is. So what can you see? On the y-axis, this axis here. You see the real buttons that the model should predict, because it knows those are the real buttons. That means left button, middle button, right button. And on the x-axis, you see the prediction of the model. And this is useful because in the perfect world, in the model that works perfectly, you would expect all the clicks to be on that diagonal here. But you don't see that. You see something else. So what do you see? So this means the real value that the model should predict is left, and the prediction actually also is left. That's good. But then this here, the prediction should be left, but it was middle. 22, quite a few. And then the prediction should be left, but it is right. And then for all the three buttons. So for the middle button, we see something that, at least from my perspective, was expected. Because the middle button is so close to the other buttons that you get a lot of confusion, even though it is the middle button, you get a lot of confusion for either the left or the right button. So that's also totally expected. And finally, for the right button, that's also something that's totally expected. Also something that I would have expected for the left button. So it's actually the right button, but sometimes you confuse it with the middle button, but only rarely with the left button. And this is because of the way I created those silly mouse movements, but it's actually pretty good. Even without trying the model, I now know that this model might be good. There are some problems with it. First problem, this is only on the data the model had. We still have no idea, is it going to perform well in real life? I mean, will I do the same mouse movements? I make it a little bit interesting because I still also don't know, but it could. It looks good. Now, if you think you would never show this to the end user, something like this, and the end user would never use something like this is totally true, and you can at any time hide this thing, and you can toggle it back in later. This is just tools for developers like me. And I also haven't shown this, but while it was training, it was totally usable. So the whole thing was trained in real time, and the user would not have noticed that I'm training. Something I also did not show, but maybe it's also too late now, the hit on my GPU was immense. And also the fan of my laptop started to blow, because this takes a lot of compute power on your GPU. Uses WebGL, so that means this is zero installation. You could load this in your browser right now, but you wouldn't know which buttons to click, so don't do it, because it has horrible user experience. So that means the idea is the user clicks something, you record, at a certain point think, this might be enough data, you train the model, you get all the evaluation results, and then decide, am I going to use it for a real prediction or not? And this thing might be okay. We have one more metric, and this is accuracy per button. That means this is just a number, and this number, there's an API for it. I just could question that number, and then I could write some code. If the accuracy is above, say, 70% for all the buttons, I will enable that model, and I can just do that. Shall I do that? Yes, I'm a little bit scared. So this is no show that I'm scared. I really am. So I can toggle the prediction, and I need to open the console because all the interesting stuff is still locked here. This is very early example. So now, let's see. So what you see, I'm doing this thing where I'm pretty sure that it will be okay. So just see, oh, it looks okay. So now it will predict I'm going to click the right button. And there's no explanation for that. There might be an intuition. It changes a little bit, still right button. But this thing basically is a black box. So you have no idea why it does it. You're just happy that it does. But you get some information. You get some information down in the console. And this is probability per button. So these... Sorry. So the microphone is here. I could have used the mouse, but then I would change this. So let's stick to this one, right? So that means the probability for the right button is 75%, the probability for the middle button is 10, and the probability for the left button is 15%. That means at a certain threshold that I decided to be 50%, I will highlight that button and say, the user is going to click that button. And let's see now. So middle button, you see I'm not hovering over it, I'm just close to it. Left button, and works, and I had sweaty hands. It sort of works. You wouldn't probably say it's perfect. And it also seems to work on proximity, not on mouse path, right? Maybe a little bit on mouse path, but mostly on proximity. At least that's my impression. Would you agree? Is it mouse path? And it's not perfect, you see that. It's not perfect, but it might be good enough for anything reasonable. And we just did this on the fly right here, so it's not something that I prepared. But you might ask, is this, maybe you ask that, I don't know if you do. I'm just saying you ask, is this the right way to do, or would you rather not use proximity so much, but really the movement of the mouse? Is that more interesting? And if you value proximity or the past of the mouse movement over a proximity, that is something that you model into your model. And I will show the model now, hopefully. Sorry, just not enough space. I will need to scroll a bit. So that is the TensorFlow.js part, and all the other part I'm pretty sure all of you could also write. This is just clicking and then have a mouse listener and then have a click listener and all that stuff and prepare the data set a little bit. But this is the part where you only have very few lines of code, but you need to think about those few lines of code and have variations of this. So this TensorFlow thing is the TensorFlow namespace. I'm saying I want a sequential model. That means we have layers, they follow each other. And the first, and this, now it gets interesting. So this stuff before, maybe not so much. This says it's a simple RNN, and that is a sort of neural network that can learn from a sequence of things. And there's a lot of stuff that you don't need to know about, but this will say, I have, I'm quite sure how many, maybe it's 25, I cut the mouse movements into chunks, and then I have 5 features. That means, how does the input to this thing look like? And then this says, how many neurons do I want? And this is totally hand-wavy. You just try that out. And typically you don't want to use too many because it needs to be trainable on the browser. And you saw it is. If you take less, it goes much faster. If you take more, it might not work so well, and it also takes a lot of time. And you saw the predictions were actually real-time online. So the interesting part is the evaluation of this thing is much worse than on the other things that I will show in a minute. But in real life, it showed the behavior that people actually expected, that when I move close to a button, it should be highlighted. That's the result people expected, but actually, maybe you rather want something where the whole path, the whole movement falls much more into account. And there are other styles of neural networks that are better at this. So you decide how much of the history do you want to keep, and how interesting is the history. And I have, I have this pre-recorded because I didn't know if I would be able to make this run in real time. So this thing here, in the middle, you see it reacts much faster, or very much earlier. It was an earlier version of this thing, but it only reacts not by proximity, but of the path that the mouse describes. So it's much more expensive. It took much more resources to train, and it's still not intuitive, because if you just move close to the button, it won't do anything, because that's not how you click on a button. You don't slowly go to the button and then you eventually click. This is much closer to what you actually do. And if you want to do that, you will use a different type of machine learning model. And this different type of machine learning model is commented out here. It's called an LSTM, which means long short-term memory network. And you might see that apart from this thing here, where's this? It's the same thing. And the name is different, but the name is just name of variable. And then there's a cheaper version of it, which is called GRU. But you could just exchange that and do different experiments here. And I made some comments. Slow to train, evaluation is bad, but it actually performed really well. It's the network that I used for the second example. Good, 5 minutes left, so I will show some more code, unless there are questions right now. Questions? Yes? Yes, so the question is, have I made something like a baseline where you... And no, but exactly what you propose also was in my head. I'm just using the vector and I'm seeing what is the mouse curve pointing. It might be it works better, but I haven't done this, and also not proximity. I think it would be pretty easy to implement, but I didn't want to spoil it for myself, I think. Maybe it works better. If you do that, please contribute. It's on GitHub. Make a pull request. Maybe I would not be so happy, but please still do. It could be better. So, but the point being here, maybe the use case is silly. I'm not even sure myself, but the point here is, so this data, it never left the browser. So this stays in the browser. You can download it yourself, but it will never reach a server of someone you don't trust, in terms of privacy, for example. You don't want that, maybe. And also, the model that you're training is also it stays on your machine. It will not leave your machine. And the prediction will also be on your machine, and it will be in real time. That means you do something, and the model will predict. You didn't see any, at least I didn't see any delay. And you didn't see any installation. So you can start this, maybe not on your phone because you don't have a mouse, but you can start this on any laptop, and it will still work if you know which buttons to click. And that's the point. So if you have anything where you think that might be a good idea. This might be the right thing. Otherwise, it's pretty hard to explain why would you even do machine learning in the browser, because, for example, the browser doesn't train, at least in Chrome, when the window is not up front, when it's not highlighted, or when you look at something else, the browser will restrict the resources. So it's not the ideal platform for trading, but it might be if you're after privacy or high interactivity. So well, hopefully, to show you that it's not very hard to get this done. So this is something you could copy from pretty much any tutorial, and that's the whole model. So model definition, this part, and this part, and the other part is commented out, so it doesn't count, I guess. And the most experience that I had put into it was to make it very general with very few data sets, which is typically extremely hard. And this involves tweaking with strange parameters where there's barely any theory to it. And one of the parameters that I was tweaking was this dropout thing, and then this batch normalization. And this is just experimental. You have some intuition, and then you just play with it, and you see when it performs well. And what you see is a result of this very strong, well, sort of strong regularization. So it still works with not many data sets, sorry. So preparation, boring, training. This is training. So you have the model you call fit. That means you stick in the input, that is the mouse movements, and you get back the button. But in this case, you just train the model, tell it, this is the true data that I have, learn from it. And then there's still too many parameters that I can't explain now, but I would be able to do that in 5 minutes. Okay, and then prediction, so done. After that, this was triggered by one of the buttons, so after that, you can evaluate that somewhere, and then eventually you call predict on that. And this is again, model, stick in the X data set, get back the Y, that means the button. Or in this case, to be more accurate, the percentages of probability for each button being clicked. So you can save that to local storage. You can download that. And then you have 2 files that you can store. You can use that data to train that on just normal TensorFlow, which I also did, where I exported the data, I did the training. And then you can also export the model that you trained on a real server and load it into the browser if you really want to. And the idea behind that is maybe you want to share some training experience with other people who are willing to give the data to, I don't know, someone else, upload it to a server, and then you could train a general model, upload it to this thing here. I could do this. It's loading a remote model now, and we can see, I don't know if it's performing well. Not so much, but also not so bad. So this model that I just loaded, it has been trained on a server. Probably on more data, and still works. So with that, I'm closing it, and what I would like you to give to me is ideas. So either on Twitter or I don't know, in person. Is there anything, any inspiration you got from this? What you could do in the browser, then tell me. And if it's a great idea, keep it to yourself. Just implement it and make a lot of money. But maybe if you need, I don't know, some going back and forth, talk to me. I would be really happy. So thank you, and have a nice conference.